In this series, we're going to show you how to create a vinyl cutting project using CNC Stylus. In this project, we're making some animal stickers, like the ones on my toolbox here. We're going to go through this process step by step. We're first going to take you through creating a toolpath using Vectric and the drag knife gadget. Next, we will focus on setting up CNC Stylus with the vinyl cutting cartridge, including selecting the correct blade type for the vinyl we're using, and then setting a blade depth. We'll then go through the operation of SmartBench, which starts off with setting an XY datum, setting a Z datum, and then starting the job right through to completion. This tutorial will be split into two sections. Part 1 will focus on file generation, and Part 2 will focus on SmartBench operation. Before we can cut files, we need to do the design work in some CAD/CAM software. The CAD/CAM software will then export the toolpaths for SmartBench. If you want to skip ahead to Part 2, you can simply download the files we'll use from our knowledge base. Click the link in the description below to go there. So for Part 1, file generation. For this tutorial, we'll use Vectric VCarve Pro for our CAD/CAM software. Vectric works by defining a general job setup, drawing out basic features in 2D, assigning toolpaths to the drawn features, exporting the toolpaths to a file. Let's get into it. So we're going to start in Vectric by creating our job setup. We're going to first create a new file. So we click New File up here. Once we've created the file, we can now select our job type. For this, we're going to choose single-sided. We're now going to enter our width in the X-axis, which is this axis across the bottom of the screen. And we're going to type in here 600 millimeters. And then we're going to set our height, which is in the Y-axis, to 560 millimeters. And our thickness in Z will be 0.1 millimeter. We'll then choose material surface as our Z datum position. And our XY datum will be the bottom left-hand corner as shown on the screen here. We can then press OK, and this will now create our job setup. Once we've created our job setup, we need to now import our vectors, which will be our animal stickers. We can now go up to press Import Vectors, which you'll find under File Operations, which will open our open window. We can now click Animal Stickers, and we can press Open. This will now open our stickers, and you can see here they are individual vectors. We now need to group our stickers, so we can use the mouse to select them all, right-click Group Objects, and these will now operate as one individual object. We can now go to Edit, Align Selected Objects, and Center in Material to ensure these are centered to our job. Before we create the drag knife toolpath, we now actually need to separate these back into their individual objects. We're now going to select the object again, right-click, select Ungroup Objects, and ungroup back to original layers. And you can now see the objects are individual. This will allow us to create our drag knife toolpath later. When we create a drag knife toolpath using the gadget in the next step, we can use a dummy tool. This means we do not need to add a new tool to the database. Here we can select any tool. In this case, we're going to select the end mill 0.1 millimeters. It's careful to note here that the gadget will automatically calculate the toolpath from the center of the tool, so we do not need to worry about the diameter of the tool. Your tools can be found up here in the Toolpaths tab, Tool Database, and you can see our tools here already created. We are now going to create a toolpath using the drag knife gadget in Vectric. This comes pre-installed into Vectric, so you don't need to install anything. The drag knife toolpath is needed as we need to accommodate for blade offset, which I'm going to explain to you now. Blade offset refers to the tip of the drag knife and the offset. The tip of the drag knife is offset by a small amount from the pivot center of the tool. This allows it to swivel as it cuts. This offset value specifies the distance between the central axis B and the tip C. It's careful to note here that the offset we'll be using is 0.2 millimeters. So we're now going to create our toolpath. We do this by first selecting all of our objects. We can do this by clicking and then holding Shift between clicks to select each individual item. Or we can use our mouse and drag and select these as a whole. Once we have our item selected, we can go to the gadgets at the top, click on Drag Knife Toolpath, and then we have our drag knife toolpath window. Here we need to enter the following values. So we're going to use a cut depth of 0.1 millimeters. And we're going to use a swivel depth, which is the depth at which swivel actions are inserted, as 0.05 millimeters. This should be shallower than the cut depth of the appropriate tool. Passes will be set to 1, and we can untick the vector start points box. Our blade offset, as explained earlier, is going to be 0.2 millimeters, and our tolerance angle will be 10 degrees. Here, as mentioned before, we're going to use a dummy tool. We already have here selected a 0.1 millimeter end mill, which is in our pen plotting tools we created in the earlier video. We can now press OK, and this will calculate our drag knife toolpath. If I zoom in on these sections, you can see how the drag knife toolpath is different as it adds extra movements for swivels. You can see this on various different corners. Our drag knife toolpath is shown over here. So now we have our toolpath. We're going to export this as a GCode file for SmartBench to understand. We need to first select our toolpath, which will then be highlighted in blue under the toolpaths. And now we can press save. We're going to make sure we are saving the selected toolpath, and the toolpath name will be shown here, which will be saved. We can select our post processor as Yeti Tool SmartBench, and we can now press save toolpath. We can save our toolpath here. In this case, I'm overwriting a previous file called animal stickers, and press save. We're going to press yes to replace the file. This has now saved our GCode file, ready to transfer to SmartBench. Before we get into the technical data, let's look at different types of vinyl. There are 3 different main types of vinyl. There is self-adhesive vinyl, which is perfect for signage and branding. This comes in many different colours and thicknesses, which normally has a paper backing, which you can then peel away. You can also process heat transfer vinyl, which is great for t-shirts and clothing. Heat transfer vinyl does not have an adhesive backing, instead is fused to clothing using heat such as an iron. Also source much thicker, rigid vinyl, which comes in a varying range of thicknesses. CNC Stylus has been designed to process thinner materials such as self-adhesive vinyl and heat transfer vinyl. We're going to focus on these in this tutorial. You can potentially process thicker, rigid vinyls, but this needs to be taken with a different approach. One more thing to note is where can you buy vinyl from? You can buy vinyl from most online shops. We've put a few links on our large base, so please go and check that out. What blade should I use? There are 3 different blade types, which are defined by their angle. We've included different blades in the box, which are 30 degree, 45 degree, and 60 degree blades. How do I identify which blade is which? Blades ship with a protective cap, and its colour indicates the blade angle. Watch out though, because these can easily be mixed up. Yellow indicates 30 degree blades, red indicates 45 degree blades, and blue indicates 60 degree blades. What are the different blade types used for? The steeper the angle, the deeper the blade can reach, such as 60 degree. Therefore, this is used for cutting thicker materials. However, this can add more cutting load and can sometimes cause tearing. A shallower angle, such as 30 degree, has less cutting load. This cannot reach as deep and therefore is used for thinner materials. A good rule of thumb is to use a shallower angle as the thickness will allow. How do I change a blade? The blade sits inside the vinyl cartridge and is held in place by a magnet which sits on a bearing. This allows the blade to swivel and rotate. The blade can be removed by pressing the ejection pin and pulling the blade out from the cartridge. To reload the blade, simply push the blade back into the hole. When you finish using your blade, be sure to replace the protective cap. This will stop your blade from getting damaged or blunted, and the colour will help identify the blade angle. What spoil board should I be using? For this project, we're processing thin vinyl, so we can actually use the same technique as we used for drawing with CNC Stylus. We're going to show you a few clips of those videos now. Although we're using paper, it's exactly the same for using vinyl. When drawing with CNC Stylus, we need to ensure we use something rigid and flat. We'd recommend using a 12mm double melamine faced MDF board. This is to ensure we have a smooth surface to draw on and a smooth surface for our lower wheels to roll along. Do I need a self-healing mat? If you are only drawing or cutting thin materials which have a backing paper, then you only need a flat, rigid spoil board, as discussed earlier. If you're cutting rigid materials all the way through, or if you're locking out the movement of CNC Stylus, then you may require a self-healing mat which you can bond to your spoil board. In those examples, that would allow the blade to punch all the way through the material without blunting or damaging the tip. How do I hold material down to cut? Just like in our drawing tutorial, we're going to use frog tape to tape along all edges of our material. We're going to start by cutting our vinyl to the size of our job as defined in our file. Just like before, we're going to use frog tape to tape down our vinyl. We're going to tape along all the edges, and we're going to start by taping the corners, and that allows us to keep it as flat as possible. Now that's all taped down, ready for our next step. We're now going to set the X-beam for cutting vinyl. Again, this is exactly the same as when we process paper for drawing. We're going to show you a few of those clips now. Please don't be alarmed if you see paper, it's exactly the same for cutting vinyl. When using CNC Stylus, we need to ensure the wheels on our upper beam do not roll along the material surface, as this can cause creasing and tearing. To do this, we'd actually recommend using a gauge, something like a piece of material, to ensure our wheels are set a fixed distance above the paper. So as you can see, from using our material as a gauge, we now have a fixed gap between the wheels and our paper, and this is consistent from this wheel on one side straight across to the wheel on the other side. So now we can tell our beam is nice and flat. One important thing is to ensure our clamp handles are tightly secured so that our beam cannot move up and down while we're drawing. We're now going to talk about one of the most important factors when cutting vinyl. Setting the blade height is the most important factor because if your blade height is not correct, you'll either not cut deep enough into your material or you'll cut too far through your material through the backing paper. We're first going to make sure we select the correct vinyl blade. For this thickness of vinyl, we're going to use the 45-degree angle blade, which has a red cap. To set the blade height, we're going to first insert our blade into the vinyl cutting cartridge by first removing the red cap and placing it into the cartridge. We can now adjust the gold locking ring by loosening this off, and we can now twist the inner barrel of the cartridge to extend the blade from the barrel. The vinyl cartridge works by allowing this surface of the barrel to run along the top surface of your material. So we need to ensure the blade only extends the thickness of the material we wish to cut. As the blade is very, very small, we've included a checking jig in the box to allow you to easily see the blade. We're going to align the cartridge with the side, and we can now visually see the blade extending from the barrel. This is going to make it easier for us to adjust. Now that we can visually see the blade is extending from the cartridge, we're going to make some micro adjustments to ensure the blade is set to the correct depth. We don't want to be cutting through the backing paper, but we do want to cut all the way through the vinyl. To do this, we're going to cut a small sample. Laying your vinyl flat on your bench and applying some light pressure, drag your vinyl blade across the surface. You can do this multiple times. We can now check to see if the vinyl cutter has punctured the back paper. We can see here this is cut through the vinyl, but we can check to see that the paper is in fact still intact. Here we have a few examples to show what happens if the blade does not stick out enough from the cartridge, if it sticks out too far from the cartridge and punctures through the backing paper, and here is one that is absolutely perfect. We've cut through the vinyl layer, but we've not cut through the backing paper. This one shows we've not cut through the vinyl layer on the top at all. So the blade was not extending far enough from the cartridge. The next one is an example of where the blade was sticking out too much from the cartridge. This is cut through both of our layers, so you can see it's cut through the vinyl in the green and the white backing paper. The final example is where we've set the blade height to be exactly perfect. We've cut through our top vinyl layer, which you can see me peeling away here, but we have not punctured through the paper backing. To give you an idea of how far the blade extends to achieve that, we can now align our cartridge with our jig and see that the blade only extends 0.3 of a millimetre, roughly, which is the same thickness as our vinyl. This is not much at all. The last thing to do is check your locking ring is tight so that the blade height does not change during your job. How do I load a vinyl cutting cartridge into CNC Stylus? You'll first need to select the correct size collet. For the CNC Stylus and the vinyl cutting cartridge, we select size 16 to 15. The nut, which features an eccentric washer, requires the collet to be fitted from a specific side. Here you can see the thinner part of the washer at the top and the thicker part of the washer at the bottom. Holding your nut with the thicker part at the bottom and the thinner part at the top, insert your collet and push up until it clicks into place, and then push down to release. If you've fitted the collet correctly, you should be able to invert the nut and the collet will hold in place. Next, we can pre-fit our nut and collet to the stylus. Now that we have the collet fitted to the stylus, we need to load the vinyl cutting cartridge. When we're loading the cartridge, we need to focus on clamping onto this shoulder here. We can insert the vinyl cutting cartridge into the collet, and while holding it with one hand, we can tighten the nut until it grips. We can now micro adjust so that the cartridge is straight and tighten. The vinyl cartridge is mounted in the stylus. You should have an extension of around 15 millimeters from the face of the nut to the tip of the vinyl cutting cartridge. One final thing to note is to ensure that your vinyl cutting cartridge is parallel with the axes. Here is a very bad example of how the vinyl cutting cartridge is not parallel with the axis. Here is a good example of a parallel setting. It's now time to load CNC Stylus with the vinyl cutting cartridge into SmartBench. This is exactly the same as we did for the pen plotting video. Here's a few clips of us doing that. We're now going to load CNC Stylus into SmartBench. Using the loop, we're going to lower the stylus into the Z head and ensure the boss sits securely and flat into the collar. We're now going to use our 6mm driver to tighten our hex bolt. By inserting the tool, the rule here is to tighten the bolt until you feel resistance and then continue to turn for 1/4 of a turn. This does not need any more than 5 Nm of torque. So now we've selected the vinyl, the correct blade to use, and we've loaded the vinyl cutting cartridge and stylus into SmartBench. We're going to set our XY datum. This needs to coincide with our Vectric file which we created earlier. So I'm going to move the axis in the Y and in the X, and we're going to center the tool over the corner of our vinyl. Going to move the stylus down a little bit so I can get a closer look. This looks like a good starting point, so we're going to set our datum and press yes, and you'll see a green light to say this has been accepted. Now it's time to set our Z datum. We can't use the Pro plate in this case, so we need to do this manually. We're going to move the stylus down until the point of our vinyl cutter touches the material. We're then going to move this down a further 2 millimeters. This is going to put CNC Stylus in the middle of its range of movement. This means that we can accommodate for flatness across our sheet and our material. We're going to first move our Z axis down so that our stylus is closer to the material. I'm now going to switch to the tortoise mode so that it moves the axis a little bit slower. And just as we get to the top of the material, I'm then going to stop. We can now switch to move in 1 millimeter increments, and we're going to move this down 2 millimeters. 1, 2, and we can now press set, and you can see the green light which will then accept our Z datum. Now we're ready to start our job. We've already sent the file to the console, so we're going to select our file and get it loaded. We're now going to open the file chooser, select our job, after the file's been analysed, we're going to check our job for errors. Our file has now been checked and is good to go. We can now press start. Now that our job's finished, we can see the job completed screen, and this job took 4 minutes, 10 seconds. Now we're going to show you how you remove the vinyl cuttings from the paper. Here you can see our finished sticker. Not a huge fan of penguins, but I'm sure this will look great on my toolbox. There we go. Thanks for watching. We're going to show you some of the top 5 mistakes that we see when using vinyl cutter and CNC stylus. The first one is cutting through the backing paper. You need to ensure you set the correct blade depth so you don't cut through the backing paper and the vinyl. We just want to be cutting through the vinyl layer to give us a clean sticker. If you start seeing this, it's worth revisiting our section on setting the correct blade height, where we use vinyl to check the blade depth. It's really worth getting this right to save your job. Number 2 of our top 5 mistakes is ensuring your vinyl cutting cartridge is parallel with the axis. This is going to ensure you get a nice clean cut and there's no tears or breaks in the vinyl. If you start to see tearing at the side of your sticker, that will likely be the cause, so I'd go and double check. The third biggest mistake we see is using a damaged or blunt blade. We'd recommend using a jeweler's loupe. We have an example here of 9 times magnification. It's not easy to see with the naked eye, so always double check your blades. A blunt blade can cause tearing and snagging at the edge of your sticker. In at number 4 is selecting the incorrect blade angle. Be sure to replace your blade caps so you know which one is which. Remember, the larger the angle, the thicker material, and the shallower that angle, the thinner the material. Finally, at number 5 is ensuring your vinyl is flat with no bumps. Thanks for watching this video. I hope you find it helpful. Please go and see our knowledge base. We've created loads of videos like this that are going to help you with projects.